Good afternoon, friends. You are most welcome to Think Eyes channel. Today we are going to discuss Practicing Anthropology by MAAN IGNOU, and our topic is Anthropometric and Physiological Dimensions in Practicing Anthropology. हमने लेक्चर 1 पहले डिस्कस कर लिया था, लेक्चर 2 हम कंटिन्यू करेंगे. In the early stages, ergonomics anthropometry dealt with adult humans as their main subject, as initially ergonomics was only interested in the work environment of humans. However, with time as interest in ergonomics expanded to incorporate newer areas like home ergonomics and leisure ergonomics, it became necessary to seek help and benefit from the information present-day anthropometry could provide about the different stages of human growth. Children, young people, and adults, including the elderly, are differentiated in anthropometry by using ontogenetic periods as the criterion for categorization. Anthropometry is well endowed with ample measuring methods to study these groups. The various kinds of measurements used are length measurements for infant conducted in the prone position with the help of a special kind of a librometer. In adults, the same measurement is conducted in the sitting position with the use of the vertical anthropometer. There are methods of measuring which are conducted at a distance. They are most suitable to both the investigator and the subject and are called as non-tactile methods. This type of method is usually applied on disabled people and was first practiced by a Swedish researcher named Thorin, 1994, with the use of a set of mirrors and cameras and connected to CAD or CAM software. Such a non-tactile method where there is use of cameras and softwares are called photogrammetric methods. Photogrammetric methods. These methods assist to evaluate the malformations, deviations, and dislocations in the structure of the body. These methods assist to evaluate the malformations, deviations, and dislocations in the structure of the body. More advanced and expensive methods are present to specify the shape and dimensions of a body irrespective of the position of the body and the changes observed over time. Das and Cozy, 1994. Design anthropometry is also dependent on statistical methods. Individuals exhibit a variety of body dimensions from tall to short and different body features ranging from long to short boundaries. These characteristics are of course found in every population or group. When a said population is characterized or assessed in terms of numbers, anthropometry makes use of fundamental statistical means and methods. The commonly practiced means are followed according to the Gaussian distribution. With the help of statistical methods, it is possible to design products for 95% of a population. Before going any further and discussing other newer and interesting methods of measurements for design anthropometry, let us have a brief knowledge about the earliest and the conventional tools which were and in many cases still used. These were basic and simple tools applied for anthropometric measurements. They did serve their purpose, and equipments like calipers and measuring sticks are even used today. Figure 1 shows a range of such traditional tools, and they are used for measuring heights, width of pelvis and shoulder, and also circumferences of chest and waist. These are the tools. Look at these. Sources: Heron, R.E.'s chapter on anthropometry definition, uses and methods of measurements in the International Encyclopedia of Ergonomics and Human Factors, 2006. Though these equipments are plain and uncomplicated to look at, however, they are to be carefully and systematically applied to get adequate amount of authenticity. It is necessary to have knowledge about the landmarks and how to put the measuring appliance on the body. this needs to be done in a standard way. Over and above these traditional methods, new modern methods of measurements have been introduced in the few decades that have passed. Anthropometric tools have transformed drastically and have ushered in newer, more sophisticated mechanisms. These technologies have been much backed by the advances achieved in computer and shape sensing skills. Now, instead of standard metallic measuring devices used to measure body parts, 3D and 4D computations, image models on computers, and fractals are being made use of. These work with the help of multidimensional sensing equipments which depicts the human form and function in a better and subtler manner. Newer changes in anthropometry began in 1960s with the realization that the human body is uneven and exhibits a three-dimensional dynamic body form. This requires various innovative instruments and mathematical constructs to obtain better results. So from the 1960s onwards, we find more application of mapping approaches where contour and coordinates were used. Mathematical methodologies with the help of polynomials, NURBS, B-splines, etc. were used, which helped to signify the uneven multidimensional body characteristics. Heron 2006. Conventional anthropometry was largely limited to surface measurements of the body alone, with some restricted use of X-rays in the past. New technologies like magnetic resonance imaging (MRI), computed tomography (CT), positron emission tomography (PET), etc. have opened up new avenues for generating new forms of collecting anthropometric data which was previously considered to be not possible. Knowledge of body dimensions and movements in the internal body can give vital data which can cater to ergonomic requirements. For example, it would certainly be helpful to know what happens to the geometry of internal organs and systems during the performance of various tasks and when the body adopts different postures. The 3D images and its processes of the recording and instrumentation methods are of immense help in designing and fitting purposes. It is found today that the uses of not only 3D computer models but 4D too are of great assistance to different ergonomic applications. With the use of such imagery in cinema industry, interest to produce better, precise and more adaptable computer generated models have been designated or designed for ergonomic uses. This method of designing anthropometry has developed drastically, and 3D and 4D images of human models now include details of human form and functions in Axis. This helps engineers and design anthropometry experts to utilize them for anthropometric and ergonomic purposes. We will try to understand more about the facilities that these computer generated models provide in the section of on uses of anthropometry. We will try to understand more about the facilities that these computer generated models provide in the section on uses of anthropometry. Coming back to other methods and measurements of the anthropometry, the measurement of workspace envelope, area surrounding, etc., including diverse occupational pursuits, in a vital part of ergonomic design. The space envelope accessed by the body while doing a job is more than the space used by the body itself. Today, the methods used for the designing of workspaces which are convenient for the body to work better are the non-contact three-dimensional video imaging techniques. They are small, easy to handle and are affordable. In terms of measurements, The strength of human beings is also an important aspect in the designing of tools and equipments in many different ergonomics functions. With good enough skill, proper and consistent strength information may be collected with simple means like the modern electronic dynamometers and strain gauges. Uses of design anthropometry. Anthropometry or anthropometric measurements are applied in an astonishingly extensive type of specialized and mechanical areas, for example, industrial design, clothing design, forensics, architecture, etc. In ergonomics itself, anthropometry is employed to create design for humans' use. Design anthropometry fundamentally analyzes the statistical information about the distribution of body measurements among people to enhance and improve manufactured articles. The prime purpose is to design products like tools, workplaces, and surroundings in such a way which will help people perform better and more efficiently. So, it is the creation of the best human worker, the tools, hardware or software, and the operative ground or operative background, physical or psychosocial, to augment human performances. This match is known as the human machine interface. Hence, anthropometry in general and design anthropometry in particular does play an important part in bringing home the point that different bodily characteristics like size, shape, vigor, grasp, influence the manner in which people carry out their jobs and reveals in order to perfect these the human machine connectivity has to be excellent. Besides industrial and clothing design, design anthropometry is also applied in designing furniture, surgical apparatus, farm appliances, aircraft controls, etc. We may say that design anthropometry deals with anything that exhibits a human environmental interaction. This need for anthropometric data is now acknowledged by engineers, architects, companies, and designers alike while designing products for their uses or for their users. And in this, anthropologist and anthropologists with anthropometric knowledge can offer their skills. We will find that there is great difference in application of anthropometric information and measurements for different equipments or material. For example, a casual t-shirt may not require exact body measurements and can be created in approximation. This we may call the soft fit, whereas a scuba diving outfit would be categorized within a hard fit as it has a purpose to fulfill and must conform to the proper body dimensions of a person, whether male or female. Here the measurements of the outfit have to be precise as it involves safety and comfort concerns underwater. The role of anthropology with its provisions for training in anthropometric measurements thus provides attractive offerings in the form of private companies and government organizations, from measurements on body parts to ascertaining clothing size to other body gears. For example, creation and selling of shoes all involve expertise in anthropometric studies. We have elaborately mentioned the 3D processes of measurements above. These 3D scanners have interesting uses in design anthropometry. Other than them, we provide an explanation of some more attractive and beneficial uses below. In some cases, it may be found that 3D laser scanning technologies are applied for reverse engineering and animation. This is done for commercial purposes. 3D scanning creates a precise imitation model in electronic or digitized format. In matters where bodies cannot be touched, this provision is much convenient. It also involves minimal measurement time after conversion to digitized layout. It can be then introduced to free-form engineering computer-aided design CAD equipments to be created with the use of procedures like computer numeric control, CNC machining, fuse deposition, manufacture, and stereolithography. The benefits of such measurements to the anthropometrist are that with the absence of the real individual, the scan can be measured at any time without any complications. 3D scanning has helped in conducting of large number of national surveys. Nowadays, with the use of 3D scanners and statistical means like principal component analysis (PCA) and multivariate regression, body surface investigation may be done in furniture manufacturing industries, which can help in using digitized models for torso shapes to create chair and seat size or seat designs. This will help to offer secure and relaxed support for a huge gamut of the population for which these are designed. Along with these, softwares are developed to obtain torso data and to express the torso with even surface band. The process is built from basic anthropometric features like stature, body weight, and gender, assets in the improvement of office chair design. The PCS and regression procedure of analyzing torso shape gives any sought pattern of body dimension. Different mixes of stature and body mass index can be noted for men and women to attain boundary cases, which can be used in the design of seats. The outcome can be applied to evaluate the suitability, size, and adjustability of products like seats, chairs, clothing, shielding appliances, etc., which can be eventually utilized by different individuals of different body structures. Another example is the whole body laser scanning, which is used for body surface anthropometry investigation. This scanner is primarily used to learn about the body shapes and their postures when seated. Earlier, whole body laser scanning used to concentrate on standing and uncorroborated seated position. However, the outcome was not enough to use in seating design. Now, with the new and better means of measuring and scanning, models can be built who can be used to envisage seated body shape and posture for appliance or for applications connected to crash safety. Spatial scanning methods are used to study the seated position and body shape of children. The data from these whole body scanners and handheld scanners are combined, along with the documentation of skeletal landmark sites. Here both digital and manual methods are used, and finally visual recognition of the scanned information is done. This is known as whole body surface anthropometry for children. The result is that models of children body shape is understood to use in the designing of products, which includes safety, protective equipments, and clothing. Another way anthropometric measurements come in use is by conducting the adult whole body surface anthropometry model. Here a whole body 3-dimension surface prediction model is used. Here an amalgamated model using sample of 2,400 American adults, 983 men and 1,023 women is used to envisage body, surface geometry, surface landmark positions, and inner skeletal joint sites. The model can be used by taking help of body dimensions like stature and body weight. The desired results is gathered by keeping the stature and BMI body mass index constant, and the torso shape boundaries are deployed. People having the same BMI body mass index may have variant body shapes. In men, the basic distinction marker is chest muscles mass versus abdominal fat. In women, torso body shapes are in contrast in terms of fat accumulation. The results from the parametric model is the conception of virtual populations. From this, target population can be used to form both representative and boundary cases in the 3 dimensions. http mbreed.umtri.umich.edu mbreed, that is the website. Measurements made with the use of computer supported design techniques like CT scan and then images converted to models by taking geometric indicators into consideration like the femoral head offset, femoral head center HC, femoral head diameter, femoral head relative position, position of shaft isthmus, neck shaft angle, bow angle, femoral neck length, canal flare index, femoral length, and canal width at various locations can produce perfectly fitted femoral stems for artificial attachment without cement for hip joint replacement. Raval et al. 2012. However, in this discussion, we must understand that what may be perfect for the people of one country might not work for another. It is important that country-specific measurements are carried out on people to get the best out of design anthropometry. This is an important factor in the study of population. For example, in India, latest thorough, the complete anthropometry in the entire population is not clearly available. In terms of automotive design and related design applications, anthropometric information of the people of the nation is imperative. Nowadays, seeing the amount of dedications being devoted towards such perfect designs and comfort of all individuals, developing and underdeveloped countries are also trying to do their best in spending their assets through the years on creating databases. Such databases become useful to companies and factories involved in designing either automotive or others. In India, some organizations in the past have been associated with projects which emphasizes areas of Indian anthropometry. Size India is a project which has come up in the recent past, which has been created with the growth of industries and a genuine need for India-centric designs, which demands an entry to the newest and convincing anthropometric database, Kulkarni et al. 2011. The uses of anthropometry we find are many and varied. Design anthropometry has also its importance in inclusive designing. Inclusive designing can be defined as design typically involving the identification of need, creation of solutions to meet that need, and then a review to ensure that the need is met. Consequently, when considering a design approach, it is necessary to also consider the measure of success, that is the point at which the design is considered to have met the stipulated requirements. However, the stipulated requirements themselves have the potential to exclude certain section of the population from using the resultant product. As an example, consider a kettle that must boil a minimum volume of water and therefore has a minimum associated weight with the water inside it. Users of the kettle will be required to have enough strength to lift that minimum weight, and even not having such strength, will not be able to use the cattle irrespective of other design decisions made. A design anthropologist needs to look beyond the twin aims of designing for the typical user and designing prostheses, making accessible interface for older people. Effective application and interface design address the dynamic diversity of human population. Older population or older people have significantly different and dynamically changing needs which require user sensitive inclusive designing. Older people are different from younger people or young people and can be divided into three groups: fit older people who do not appear nor would consider themselves disabled but whose functionality, needs and wants are different to those they had when they are when they were younger. Frail older people who would be considered to have one or more disabilities, often severe ones, but in addition will have a general reduction in many of their other functionalities. And third, disabled people who grow older, whose long-term disabilities have affected their aging processes and whose ability to function can be critically dependent on their other faculties which may also be declining. Other major characteristics of older people when compared with their younger counterparts include the individual variability of physical, sensory and cognitive functionality of people increases with increasing age. Older people may have significantly different needs and wants due to the stage of their lives they have reached. Also, there is a need to design inclusive products to accommodate a number of people experiencing a loss of functional capability, and successful inclusive design requires a balance between the demands a product makes of its users and user capabilities along with a number of design metrics and data to enable their evaluation. Design research tends to focus on accommodating single primarily measure capability losses. The reason for this are twofold. First, single measure impairments are often the most noticeable and therefore are the easiest to inspire the necessary motivation to address them. Second, such impairments are the easiest to understand and are comparatively easy to compensate for as there are no complex interactions with the other capabilities. Unfortunately, many people do not just have single functional impairments but several. This is especially true when considering older adults. Consequently, designers need to be aware of the prevalence of not only single but also multiple capability losses. Inclusive design approach incorporates a user capability ranges that does not configure an average user. This has the advantage of enabling the manager and designer to consider all potential users with multiple combinations of capabilities. We now move to our next area of discussion where we will attempt to see how anthropologists with anthropometric training can fit oneself into a career outside academia in designing of various equipments. Practice of design anthropometry by anthropologists. It is of course difficult to plainly mention jobs or positions in which anthropologists can practice the techniques of anthropometry to enhance their career options. However, there are non-academic professions for students or individuals suitably qualified and holding degrees in physical anthropology. Beyond academic circles, such researchers work for private and public agencies where a variety of anthropometric studies, both traditional and modern, are conducted to ascertain different sizes to produce and manufacture equipments, apparels, workstations, etc. It is generally found that in companies or sectors connected to ergonomics or design anthropometry, professionals trained in human engineering, ergonomics, biomechanics, psychology, etc., have always been the preferred choice. However, the situation is changing with more and more people with anthropological background being given the opportunity to exhibit their anthropometric skills. Now anthropologists are professionally accepted in clothing industries, aerospace industries, consultation firms, etc. To better garner skills in anthropometry, anthropologists interested in making out career out of it should also associate themselves with specific professional courses on anthropometry, medical or health areas, anatomy, genetics, nutrition, biostatistics, kinesiology, biomechanics, human engineering, etc. A strong mathematics and science education can help in elevating the chances to success in profession associated to design anthropometry. It is found that mostly in the private sectors, anthropologists find themselves working side by side with ergonomic experts and designers. In such scenarios, more proficient and the more proficient the anthropologist is in advanced anthropometric abilities, the easier it becomes to work with experts. It is an added benefit if the anthropologist has the ability to also excel or at least exhibit knowledge of research documentation, proposal and report writing, computing and graphic designing skills, and to some extent accounting and supervising. In public and private sectors, an anthropologist looking for jobs with anthropometric needs, it is beneficial if the anthropologist has knowledge of taking measurements on a living body along with skeletal material for taking measurements and understanding the living human body. Knowledge of nutrition and physical education helps. Knowledge of statistics and computers also increases chances of involving oneself in government or other agencies associated with applied anthropometry, specializing in design or more. Added requirements that can make an individual perform better in both private and public sectors are interactive communicative knack, where deliberations of ongoing programs, projects, etc. occur frequently with project heads, funders, etc. At the last, we will discuss summary. To sum up, this unit on design anthropometry guided as through an extensive description of what anthropometry and more specifically design anthropometry are. Design anthropometry is a distinct part of physical anthropology, and though it is largely borrowed from ergonomics, its importance in anthropology and anthropological research cannot be denied, as our link is fundamentally with humans for whom this specialization exists. Design anthropometry, as the unit shows, is entirely based on various measurements for the creation and production of materials and goods, be it industrial, environmental, forensic, etc. These measuring techniques have through the years seen exceptional transformation. These measuring techniques have through the years seen exceptional transformation, with handheld measuring equipments being now assisted or taken over by advanced digital graphic mediums. The unit also informs about the usability of the design anthropometry in different fields. With the progress in techniques, there has been an astonishing expansion in specialized and mechanical arenas due to design anthropometry and its sophisticated procedures. Lastly, we end the chapter by emphasizing that anthropologists convincingly trained in anthropometry and related disciplines can be involved professionally outside academics as practitioners and provide population and communities with more comfortable and better lifestyle. Thank you very much.